Okay, for section P6, what we're going to do is continue our work with quadratics, essentially. We talked about essentially 5 different ways to solve quadratic equations. Okay. And yesterday I mentioned when we calculated the first part of the quadratic formula, we calculated what I called the discriminant. And I mentioned yesterday we're going to talk about that a little bit more in detail later. Well, later is today. So we are going to first look, though, at what are complex numbers. Because what it boils down to is one of the things that could happen when we do the quadratic formula, okay, is it could turn out to be a negative under that square root sign. Okay, that discriminant very well could be negative. Okay, and so the question is, what are the repercussions of that? How does that look if we have a negative under the radical? Well, we know that if we try to do the negative under a radical with our calculator, it just gives an error. Okay. However, we learned a little bit in Algebra 2 about what to do when we have negatives under radicals. Okay. And before we look at the definition of a complex number, okay, let's just say for argument's sake that we wound up with a discriminant value of negative 25, because that could very well happen. Okay? So to review, what we learned in Algebra 2 is that when we have that situation with a negative under the radical, okay, we can separate that into negative 1 times 25, which is the same as negative 25. And then that square root of negative 1 we define to be the letter I. Okay? And ultimately, this number is not a real number, it's an imaginary number. Okay? So far all we've dealt with was real numbers in this class, but now we're going to be dealing with possible imaginary numbers as well. And so the final answer here, if I simplify both square roots, okay, I wind up with I times 5, and the proper way to write that would be 5i. Okay? So if it turns out to be a perfect square under the radical that's negative, okay, then our answer is always going to be something I. Okay. If it turns out that the square root is not a perfect square, like square root of negative 7, okay, we will still separate and then write I radical 7. Okay. And so notice this time when it's a radical number, okay, the I belongs out front of the 7, not behind it. Okay, if you put it behind it, it might look like it's still under the radical, which it's not. So we always put the I in front. Alright, and then finally if we have something like negative 32 square root, okay, and we separate that, and it turns out that the 32 is not a perfect square, but it can be simplified into, say, 16 and 2 like this one can, and we have I and 4 and radical 2. Okay, the proper notation for that when we have all 3 parts is to write the I in between, so we'd write 4I radical 2. All right, questions so far? All right, so let's get to this idea of having what we call a complex number. Okay. So the definition of a complex number is anything that can be written in the form a plus bi. Okay. And a and b are real numbers, so these numbers are essentially like coefficients. Okay. The real number, the a part is what we call the real part. And the b part is what we call the imaginary part, and this a plus bi is what we call standard form. Okay. Now, if I were to make a list here of some numbers, like let's say 4, okay, question I would ask is this a complex number? Okay. Again, all we have to have is it can be written in this form. So since I can write 4 as 4 plus 0i, okay, the answer would be what? Yes. Okay, 4 is a complex number. Okay, is 4 an imaginary number? No. Okay, but it is a complex number. So every real number that we've dealt with so far in this class also falls under the category of complex numbers. Okay, so the complex numbers are all the real numbers, okay, plus the imaginary numbers as well. So that means the complex numbers is more vast than the real numbers. True? Okay. So typical numbers that we'll be working with that are complex but also imaginary might be something like 2 plus 3i. Okay. Might be 4i itself. Okay. So these are all complex numbers. Okay. All right. Now, what we're going to be asked to do with complex numbers, besides interpreting the solutions to quadratic equations like this, okay, is going to be adding, subtracting, multiplying, and dividing.